On this teardown I am very looking forward. But first have a look down in the description on that link. There is a link to my second channel, MDF Rescuer. On that channel I do various stuff, mainly electronics projects, and check it out. So this is RCCB residual current circuit breaker, or RCD residual current device, I think is called. And I would like to see what is inside. This one is old. As you can see, here is maybe date. It's 2008, so its warranty is over and it isn't working because this piece was thrown. To open it went easier than I thought, but as you can see, there was this star type head screwdriver was needed. Here you see some kind of scheme. I am expecting there some coil. So let's see what is inside. Oh, whoa! First time what I see inside. I'm going to give you a close-up. I need to turn on my light and automatically should turn on macro mode, because then the camera has enough light for macro. Whoa, interesting, the coil is there, very interesting. And also this mechanism is very interesting. Whoa. So here is the coil, some kind of differential coil. When I was first time connecting the RCCB, I thought that you have to connect their, let's say it was a one-phase device. I thought that you have connect their phase and how do you call it, earth, the yellow and green wire, you know. But then I realized that here is right on N, neutral, and you have connect there the blue wire. So first surprise for me with RCCBs was this. Of course this is Europe norm, so it can be different in other countries. Not much to look at inside, but we see that these wires are going through this ferrite, and then they go back. So really it is all about the current. What is interesting to know about RCCB is that this is, for example, Slovak manufacturer, which has set in the manual or whatever it is, the paper, when you buy it, that you have to press the test button every month. So I think nobody presses the button every month. I'm curious what can be wrong on this device. What could go wrong after some time? For example, the mechanism. I would like to try it if it's working, because I don't see something obvious which would be not working here. Alright, here I noticed something interesting, and this spring seems to be offset of misaligned, so maybe this can be problem. I have here prepared a cord which I am going to put on, or better say it, plug in. So now it's plugged in. We have direct 230 volts. This one is phase, this is neutral. So I am going to turn on my ring light and better turn off everything. So now I don't have 230 volts, and it would be maybe safer to have it with this cover. Please don't try this at home or whatever, in whatever place you want. Never try this. I don't think that I should tell that I am an electrician. I'm going to connect there something much more better than a resistor. I'm going to connect there a lamp, which will be, I think, much more safer option. Now let's measure. Oh, stupid mistake. Stupid mistake, I forgot to turn on the lamp. So let's continue and probably do it quickly. Yes, RCCB is working as I expected. What's wrong here? Maybe this phase isn't working. So it nicely turned off, but the current must have been very big. Yes, it could be, say, I don't know, 500 milliamperes. It was massive leakage current which I put there, and I would like to try all three phases. So we tried this third phase. You see, lamp is shining. Never do this because you can forget that you have their phase, and it can be fatal error. So we have phase here, and what is going to do this? Nicely turned off. Nicely turned off. Another one thing, so it's plugged off. I would like to check the test button. Still not working. Here is left only one option, and try this phase. And if this will not be working, if this will not be working, so RCB is bad. The RCB is bad. And excuse my English. Yes, test button isn't working. I found here an interesting piece. Here is some kind of pin, which presses here and triggers the turn off how do you call it, process, turn off process, let's call it like this. So it looks simple. So this is only the triggering side. Oh, here is interesting thing. Here we have a resistor, and the same what I was doing here with that lamp. That from here is taken wire to resistor and goes. Oh, it doesn't go to phase. Paradoxically, it goes to neutral. Why? Let me think about this. I don't understand. Goes to the neutral? I don't understand why. It seems to be very burnt, nicely burnt resistor. What value it is? Oh, I understand. Neutral they took from here, not from here as I did, and it goes to this phase. They took it from the opposite. I took neutral from the input, but they took it from the output, and I give it to the output phase, but they give it to the input, so they do it reversely, and it seems that our problem is here because this resistor, let's find what value it is. It would be very interesting to know. Quite a big one. Is it possible? Such a big value? Maybe the resistor is burnt. Very interesting. Alright. So let's find if this has connection between this, and it doesn't have. So this is our problem. I think it would be nice to doesn't damage this trigger mechanism, because it's working. It's working nicely. I would like to repair this RCCB. Now it's there. And we don't have connection here. That's our problem. it seems that I was a little bit mistaken, and as you can see here, we have resistivity, but not between here. Yes, not between here, but between here. And when I am thinking about this, this doesn't make me any sense. So we are going to check it if it works. I managed to get there the spring, but it seems very unhappy. You see how it's acting here? Alright, so you see what is problem on our plugs, that you can connect it reversely, but nobody cares about that. It's alright. So I am very curious about that test button. Very curious. No, the test button isn't working. Indeed, isn't working. I personally do believe that this piece was connected back in the factory. Is it possible? We also doesn't have the electricity, the resistivity here. So can this connection trigger the RCCB off? Let's try. No way. No way. And it is all what is this thing doing. So this is my conclusion, what I found. Now it's everything under electricity. Here is the face. So this should turn on the light. Oh, now it's under the electricity. Let's turn it on. So this should turn on the light. And The connection is alright, as I see. When is this turned on, this piece really takes electricity from the right place and is connected alright. But I think what is wrong is this resistor. This resistor is maybe broken or something, and the value is very critical and it has got old. But as you can see, when I take electricity from this place, we are going to make the same connection what would the test button would do, and would take the electricity from this springy wire, and what it does, triggers off the RCCB. So the connection is alright. My conclusion here is that this resistor for test button has too much high value, so it can't make enough leakage current goes to it could turn off the RCCB. So according to Ohm's law, I set into my equation voltage 230 volts and desired current which I want it could flow through the circuit, and this RCB has trigger current, as you can see, 0.03 amps, so it's 30 milliamperes. So to have it higher, better to have it higher with some I set into my equation current 50 milliamperes. So the resistor value which I need is 4K6, and it's nearly perfect because we have 4K7. We have 4K7 as a standard value. So I'm going to unplug this and finally choose the right value which I want. So my guesses were wrong, but 4K7 seems to be too high to me, but alright. For that short period of time, it probably will be safe. I hope it will not burn on me. So hopefully this is the last measurement. There is my phase wire. And let's test it. Perfect. Let's try if it's hot. It isn't. So I think our RCCB is back in business, and I have it for free, so that's perfect. Let's try it again. Nice, nice. So guys, thank you for watching, and please have a look down in the description on that link of my second channel. See you.